First ionization energy is the amount of energy required to remove the first electron from an atom. The periodic table is primarily organized based on first ionization energy. Electron shells of noble gases are fully filled, and thus are the most stable. As previously mentioned, electron can split itself, with proton as a pivot, but usually electrons do not like to split in order to maintain its zinc equilibrium. Neon 10. All slots in the outermost shells are filled. Electrons do not need to split, and the system is stable. Fluorine 9. An unfilled slot in the outer shell requires 7 electrons in the shell to split to attend to. It has high tendency to absorb 1 electron to cover the slot. Sodium 11. A lone valence electron needs multiple splits to fill multiple slots. It has high tendency to jump off the shell. Ionic bond. So 1 electron from sodium's third shell jumps to fluorine's second shell, completing both atoms' second shell. Then sodium's positive charge attracts fluorine's electron to balance charge, forming an ionic bond. Covalent bond. Orbital hybridization is the adjustment of electron orbitals' angles and sizes to the most energy-conserving configuration under different conditions, usually to form bonds. 18. Sigma bond is 2 electrons of the same spin fused to become 1, connecting both nucleus. It is the strongest type of bond. The electron borrows momentum from its paired electron to conserve with the nucleus protons, as it needs more momentum to interact with 2 nucleus instead of 1. Also, the electron landing momentum contracts to reduce repulsion from expanded neighboring electrons. Pi bonds. A sigma bond can bring 2 parallel p orbitals close enough to form connecting belts. This is the pi bond. Only electrons with same spin can form sigma or pi bond. Metallic bond occurs in atoms with incomplete outer shells. Thus, electrons in outer shells are unstable. When a group of such atoms cluster together, the loosely gripped electrons in outer shell may connect with other nucleus and get expelled from its own shell. The atom losing the electrons becomes an positive ion, attracting nearby electrons, and the process repeats, eventually developing into a sea of positive ions attracting electrons but unable to keep them in outer shell. In such structure, electrons are free to move and orientate, connecting atoms at all angles at stretchable distances, giving such molecule higher potential to bend, stretch, spring, transmit heat and electricity, and be ferromagnetic.